All right, so this is section 2 of chapter 7, and this section is titled Distinguishing Elements of an Experiment. And in this section, we will cover the following topics in more detail: manipulation, control, and extraneous variables which threaten to become confounding variables. All right, so the basic goal of an experiment, a true experiment, is to establish a cause and effect relationship between your variables. So in other words, what you want to show is that changing one variable, the independent variable that you manipulate, reliably causes some change in some other variable. That's the dependent variable that you measure. So in order to demonstrate causality, you want to demonstrate the following. Firstly, you want to demonstrate that the cause happens before the effect. And logically speaking, the cause can't happen after the effect. It has to come before the effect. So in our video game violence example, the cause, exposure to video game violence, happens prior to the effect, aggressive behaviors. It can't be the other way around, at least not if you want to claim that the violence in the video games is the cause of aggressive behaviors. And the second criterion requires a demonstration that one specific variable is responsible for a change in the other variable. And this requires ruling out alternative explanations. So you have to rule out the possibility that the changes you observe are being caused by some other extraneous variable that is irrelevant to your study. So in light of these criteria, two critical elements that we'll turn to next are manipulation and control. So first, let's turn to manipulation. And we've alluded to this multiple times, but we'll expand on the topic. So the experimental strategy requires the manipulation of variables. You have to first identify the variable that you care about, the variable that is hypothesized to be causally related to some other variable. So if you believe, for example, that music affects problem-solving abilities, then music is one of your variables. And that's going to be the independent variable that you, as the experimenter, are going to manipulate. But the next question is, manipulate how? So you have to identify the levels of the independent variable, how many levels there are going to be, and what will those levels consist of? So in the example that we considered in the previous chapter on music and problem solving, music had 3 levels. There was no music, aggressive music, and calming music. Or consider the following hypothetical experiment. Suppose you want to know whether there is a causal relationship between temperature and appetite. So appetite is your dependent variable, and temperature is your independent variable. But how many levels will the independent variable have? So maybe you want to compare people's appetite in 60 degrees and 80 degrees. So that's 2 levels. Or maybe you throw in 70 degrees. Now you have 3 levels. So each level becomes one of your conditions, and eventually the goal will be to compare appetite across these conditions, across the levels of your independent variable. All right, so think back to one of the problems that we discussed, that being the directionality problem. Well, one advantage of manipulation is that it allows you to explore the direction of a relationship. Because logically, if you manipulate A and it causes a change in B, well, the direction of the relationship has been established. A is affecting B. So in the example shown here on the slide, there is a relationship between temperature and ice cream consumption. So both rise and fall together. Now, let's say that manipulating temperature in some location causes a change in ice cream consumption, but manipulating ice cream consumption has no effect on temperature. Well, that would clarify the direction of the relationship. Temperature affects ice cream consumption and not vice versa. Now here, you can probably use logic to deduce that manipulating ice cream consumption probably won't change the temperature. You probably don't need to run another study to figure that out. It seems pretty obvious. And maybe it is. But for example, in some cases, it's not so obvious. So let's say that there is a relationship between exercise and anxiety, such that people who exercise a lot report lower levels of anxiety. Now here, people may be tempted to conclude that exercise results in a reduction in anxiety, but it could be the opposite. It could be that people with lower levels of anxiety are more likely to go and exercise. And so if you run an experiment that involves manipulation, if you manipulate exercise, if you have two levels, let's say, exercise and no exercise, and anxious people are assigned to one of these two groups, and suppose you find that people in the exercise group start reporting lower levels of anxiety compared to the no exercise group, well, now you've uncovered what appears to be a causal relationship as well as the direction of that relationship. So another advantage of manipulation is that it can help you deal with the third variable problem. So in the example shown here, the same example we just alluded to, there's this relationship between temperature and ice cream consumption. Whereas temperature goes up, ice cream consumption also goes up. But it turns out there's also a relationship between crime rates and ice cream consumption. As crime rates go up, ice cream consumption also goes up. And crime rates are also related to temperature. So if you're studying the relationship between temperature and appetite, as measured by ice cream consumption, then crime rate emerges as a potential third variable. All right, so suppose you use manipulation. And let's say you manipulate ice cream consumption by giving people free ice cream. And you find, not surprisingly, this has no effect on crime rates. And next, let's say you manipulate crime rates with extra police or something. And again, you find that crime rates has no effect on ice cream consumption. So ice cream consumption doesn't affect crime rates, and crime rates don't affect ice cream consumption. In doing so, you have demonstrated that there's no causal relationship between crime rates and ice cream consumption. And thus you have dealt with the third variable problem. And so this strengthens the case that changes in temperature and not crime rates are what cause changes in ice cream consumption. So the other critical component of an experiment is the control of variables. And again, this is done to ensure that your results are not being influenced by any additional variables other than the ones being manipulated. So you want to manipulate the independent variable, and you want to control all the other variables that have the potential to influence your results. And so these variables that need to be controlled, that pose a danger to your study, are called confounding variables, as we've talked about in previous slides. And a confounding variable is a third variable that changes systematically with the variables being studied. So throughout the past few chapters, we've examined several examples of potential confounds in various hypothetical studies. But let's look at another example here. So in this study that's being plotted, suppose the researcher wants to know whether kids prefer sweetened or unsweetened cereal. And suppose you discover that kids ate more of the sweetened cereal than the unsweetened cereal, which indicates a preference for sweetened over unsweetened. But now imagine that the cereal boxes were different colors. Maybe the sweetened box was colorful and the unsweetened box was some boring tan color. Okay? Colorful, and this is a tan color. So here we have this extraneous variable, box color, that differs systematically between your conditions. And in the context of the study, can be considered a confound because maybe the preference that you measure is a consequence of the color of the boxes as opposed to the taste of the cereal. So in order to eliminate this confound, you would have wanted to design a study in which both the sweetened and the unsweetened cereal boxes are exactly the same color. And in doing so, you have eliminated this particular confound because now your results can no longer be explained by this variable of box color since it's the same for both conditions. So we've drawn this distinction between extraneous variables, which are all the variables in the study other than the ones being investigated, and confounding variables. Now, all confounding variables belong to the category of extraneous variables, but not all extraneous variables are confounding variables. So you don't need to worry about controlling every single extraneous variable, but merely those that have the potential to become confounding variables. And that's a good thing because the number of extraneous variables in a study is typically going to be very, very large. So let's talk about the specific characteristics of confounding variables, or what has to happen in order for an innocent extraneous variable to become a big bad confounding variable. So one characteristic of a confounding variable is that it has to be capable of influencing the dependent variable. So for example, if you're measuring problem-solving ability, if that's your dependent variable, then I would say one's astrological sign probably isn't important. The color of their t-shirt probably isn't important. But their major in college, that could be important. An engineering major may be better at solving certain kinds of problems compared to an art history major. Or take something environmental. So the pattern on the ceiling tiles in the room probably won't matter. probably won't affect problem solving. But the temperature in the room or the noise levels in the room plausibly could. So as a researcher, you have to identify which extraneous variables can be potential confounds and which are not likely to be confounds. And so then the second characteristic of a confounding variable is that it has to vary systematically with the independent variable. Variables that change randomly and are not related to the independent variable are typically not a serious issue. So room temperature may only be a problem if it differs systematically between your conditions. So it is your job as a researcher to identify these potential threats, these potential confounding variables, and to neutralize them by using the proper controls.